Hello everyone, welcome to the session. Engineering mechanics divides into two areas of study. The first one is statics and the second one is dynamics. In this session, we'll see how these dynamics play a role in solving the problems of engineering mechanics. First, dynamics. Dynamics is a branch of engineering mechanics which deals with the forces and their effect while acting upon the bodies in motion. Okay, see here, the force, the motion, and their effects. These terms are very, very important while describing this dynamics. So it's a branch of engineering mechanics and deals with the forces and their effects. Okay, and acting upon the bodies when it is in motions. So here, particular bodies are in motion, and that too, these motions are occurred because of the particular forces which are acting on that particular body. But again, mainly we are going through the forces which are acting on your body, and we are trying to find that forces which are acting on your body when it is in motions. And again, these dynamics divide into two branches, which is like first one is kinematics and the second one is kinetics. We won't consider any forces during solving the problems. Like, we'll consider only the motion of the body. We won't consider any forces in it. For example, take a body on this on a horizontal plane, and now if you are trying to pull this with respect to some, see here, just consider one block on a horizontal plane, and now if you are supposed to make some effort on it to move a body, and while it is moving towards the force, and there is a friction again opposite to the particular force, which is like F, right? And now, how are you going to write the equation for this? Here, P equals to mu R. That means this is the effort which is acting towards your right side, and this is the friction which is acting towards your left side of your particular motion of your body, right? And these are the horizontal forces which are acting on your body. That means you are not considering any forces here. You are considering only the motion. When the motion is happening, you are considering that particular effort and the particular friction. That's it. So kinematics is all about the motion, but it is we are not going to consider any forces here. And coming to the kinetics, here it is motion plus force. Motion plus force. That means you have to consider the motions and you have to consider the forces. For example, take a small block on your horizontal plane and just pull it with some effort P, and here you are supposed to have friction, right? Which is like mu R. And now for this particular body, there is a weight which is acting downwards, and there is a reaction which is acting upwards. And now the equation will be the effort which is acting towards your right is equals to the friction. That means the friction is here because of the motion plus mass into acceleration, which is nothing but force, right? Force. So the kinetics will deals about the motions and the forces, but here the kinematics deals only with the motions. It won't consider any forces while solving the problems. And now in this session we'll see only the kinematics, and in the coming session we'll see the kinetics. Yes. First, what is kinematics? It's a branch of dynamics, yes, which deals with the bodies in motion without reference in the forces which are responsible for the motion. So here we are not considering any forces, we are considering only the motions, right? I just want to see in the equation of a body which is on a horizontal plane, right? The P equals to mu. That means you are considering only the motion, you are not considering any forces. And the next, to solve these problems, we require the types of motions of particular body. What are the body? Here the body may be particle, the body may be rigid. See, what is particle? Here there is no mass. We won't consider any mass. For example, if, for solving the problems, there is a problem on car, but we'll make it as a particle, or we'll assume it as a particle. We won't assume it as a rigid body. For example, ball is there, a spherical ball is there, earth is there, any heavy body is there. We are considering it as a particle to solve the problems. Right? While coming to the rigid bodies, we'll make an assumption that the body will be like a same thing. Like if it is a car, it will be a car. If it is any vehicle, it will be a vehicle. But we won't consider it as a particle. We'll consider it as a rigid body. Why you're doing this? To just simplify your problems. And now we'll see what are the types of motions we have in this particular session. So the first one is translation, and in this we have again subdivided into two parts, which is like rectilinear and the curvilinear. What is rectilinear first? See, when particular body is there, and if you are assuming some particles which are acting on it, all these particles should move parallel to each other, and that too in a straight line. Okay, that too in a straight line, and that is your rectilinear motion. And what is curvilinear? If the same body having some particles, and if the body is moving with some curve in a curve shape, that means all the lines will be parallel. All the lines are parallel, but it is moving in a curved shape, and for that we call the curvilinear motion. Simply, for the translation, all the particle paths should be parallel, whether it may be a straight line, whether it may be a curved, but it should be a parallel to each other. And next, what are the examples for this rectilinear and the curvilinear? In rectilinear, for example, if your car is moving in a straight line or a straight path, your vehicle is any motor, any vehicle is moving in a straight line, and those problems you are going to solve with respect to these rectilinear motion assumptions and equations. And moreover, for example, a ball is there, a ball is moving towards the earth with some gravity, right? And this is also a linear one which is acting towards the earth, right? It is a straight one, a linear one. So these problems also comes under your rectilinears. And what about the curvilinears? For example, one fixed point is there. From that fixed point, we have some radius, and if a body is moving in a curved path with a fixed axis of rotation or fixed axis of path, from that, if the particle is moving in such a way in a curve type with some radius, then we consider those problems are curvilinear, and we have to use that curvilinear equations to solve those problems. And the next one, we have a rotational one here. And the second type of motions is rotation, and for this we can say circular motions with fixed axis. If there is any circular motions, all these problems comes under rotation, and for to solving these circular motion problems, we have to use the rotation equation of motions, which are like angular one. For example, in the translation, if you're calling as velocity, in a rotation we are calling it as angular velocity. If it is acceleration, in rotation it is like a angular accelerations. And the third one, we have a general plane motion, and which is nothing but simply first motion, which is translation plus rotation. For example, your tire is there, okay, a moving car tire is there on a flat surface or horizontal surface. It rotates and it moves in a straight line path, right? And after some time it will reaches here, again it will rotate here, right? So it is having the rotation motion towards the forward, and it has a linear motion to move from your left to right? These problems comes under your general plane motions. In this session, first we'll see the rectilinears, and later in the coming sessions we'll see all these types of motions. Okay, rectilinear motion of a particle. A particle means we won't consider any mass of that particular one, right? we won't consider the mass of that particular body. Clear? So for this, linear motion is defined as a motion of a body which moves in such a way that all its particles move in a parallel lines. Just now we observed that for any body, if it is having a parallel lines, we call it as a rectilinear or linear motion. And what are the equations we have for this? See, before considering any equations, we have to consider two things. The first thing is the motion under uniform acceleration, and the second one is the motion under variable acceleration. So here the acceleration is constant. That means, for example, if your velocity is constant, your acceleration is zero. If the velocity is constant, your acceleration is zero. But here we are not considering that velocity is uniform, but here you are considering that acceleration is uniform. That means your acceleration is constant. That means your velocity is not equals to constant. Your velocity is varying, and that too your acceleration is constant. That means it has some value for the acceleration. Clear? And these are the equations. These are the equations for the motion under uniform accelerations. See, the first one is we already seen all these equations from your primary schools, right? And these are the equations of motion. And the first one is for final velocity. If you require any final velocity, you have to use v equals to u plus 8. And if you want any distance traveled, or this is traveled, okay, s equals to ut plus half at square. And here the acceleration what you're taking is uniform one. It won't changes with respect to the time. And next, the final velocity, here v square is equals to u square plus 2as. Okay. And the next one is distance traveled in the nth second. Okay, nth second. For example, if your body is moving the first second like some distance s, in the second it will move like distance like x. Okay, and like that it will goes on. And what is the distance it is traveled in the nth second? Okay, nth second. This nth second may be a n, or this nth second may be a 11 of particular timing, or 3, any point. Okay, at that particular point, what's your distance when it is having some uniform accelerations and the uniform velocities, and then what is the distance traveled at that particular nth second? So this is the equation, which is like s equals to u plus a by 2 into 2n minus 1. Already we know what is v and u. Okay, once again, and this u is initial velocity, and this is your final velocity, and a is acceleration, and the t is the time. S is the distance traveled, and that's it. And this is the nth second at what we require to find the distance traveled. Okay, and we'll see a small problem for these uniform accelerations. Now, the first one, on turning a corner, a motorist rushing at 20 meters per second. Find a child on the road 50 meters ahead. He instantly stops the engine and applies brakes so as to stop the car with 10 meters of the child. Calculate the retardation and the time required to stop the car. See, here your particle, you have to consider it as particle. Why? Because we already said that here for particle mass is equals to 0, right? And can you observe any masses here? No. And even though, see here in these motion under uniform acceleration, there is no mass. We have only the velocities, accelerations, distance, and the times. So while solving these rectilinear motions, we required only the particle and the motion, but not the weight of that particular one. It is like a mass. We don't require any mass. And moreover, here acceleration should be uniform. It should not change with respect to the time. And now we'll see the given data of this, which is like given that initial velocity with which the motor is rushing is 20 meters per second. And now after seeing the child, he is stopping the car, right? When he is stopping the car, the final velocity will be 0. And moreover, the distance traveled by the car is, he's seeing a child 50 meters ahead, but he applied the brakes 10 meters of the child. That means it should be like 50 minus 10, and finally he traveled 40 meters. And what we required is the acceleration or negative acceleration we required, or retardation is we required, and the time required to stop that car. The first one is retardation, and the second one is the time required. First, we'll see the retardation. See here, for retardation, that means we require acceleration. See, you will get it out that why you directly took this formula, right? See, here you have initial velocity, here you have final velocity, and the distance we have, and what we required is acceleration. What we required is acceleration, whether it is retardation or acceleration. If it is retardation, you are going to get the acceleration in the length, right? Why do this? Here we have another formula which is like v equals to u plus a t. Why you are not taking this? Why? Because here the time is there, we don't know that time, right? Moreover, in the given data we have final velocity, initial velocity, and the distance is there, and what we require to find is acceleration. So that's why from the equations of motions you are selecting this, and we know how to, what the final velocity is, which is like 0, and the initial velocity is 20 meters per second, and the acceleration what we required here, and the distance traveled is 40. And if you simplify this, what the acceleration you are going to get is negative, which is like minus 5 meters per second square. Here minus 5 is because of retardation. Retardation is nothing but opposite to your acceleration. And the next, we require time required to stop the car. See here, now we have to take this formula. Why? Because we know the initial velocity, final velocity, initial velocity, acceleration. Now we know the acceleration. What we require is time. The time required to stop the car is v equals to u plus at. The final velocity is 0, initial velocity is 20, acceleration we got from the last equation, which is like minus 5, and the t we require to solve that, t equals to 4 seconds. Finally, what we got is from some acceleration the car is getting to 0 velocity. That means your final velocity is 0, and what is the retardation that is happening is minus 5 meters per second square, and the time required to stop the car from this position to this position is 4 seconds. Within 4 seconds he stopped the car by saying a check. Okay. And now we discuss uniform acceleration, right? Now we'll see the variable acceleration in the rectilinear motion of a particle. Particle, we won't consider any mass per it. And now the motion under variable accelerations. You know what is variable acceleration? That means acceleration is varying with respect to time. So we know that the velocity of the body is a rate of change of its position, which is like ds by dt. Similarly, acceleration of the body is a rate of change of its velocity. That means if the velocity is going to change, then the acceleration will changes. So that's why you are calling it as variable acceleration. If the distance changes, acceleration changes. If the velocity changes, acceleration changes. It's varying with respect to the velocity and the displacement, and moreover with respect to the time also. So it is a dependent variable. Now this acceleration is dependent variable. We'll see a small problem on this. See here, the equation of motion of a particle moving in a straight line is, see here they given the distance traveled in some equation form with respect to the times, right? And where s is in meters and t is in seconds. Find the first we require to find is velocity and acceleration at starting point. Okay, and the time when the particle reaches a maximum velocity. Here, when velocity is maximum, just see that your acceleration is equals to 0. At maximum velocity, your acceleration is equals to 0. Remember this. Maximum velocity of the particle, and we required the maximum velocity, the time, and the velocity and acceleration at the starting point. Now, how to solve this? Okay, see, to solve the problems which are under variable accelerations, we have two methods. The one is integration method and one is differential method. Now we can differentiate this equation, but if you are going to differentiate this, what you are going to get is ds by dt. That means you are differentiating this particular distance with respect to time. Yes, your time variables is there here, so you are going to get one more equation. But we'll see that. What is ds by dt? The velocity. Right? So if you differentiate this, what you're going to get is velocity, and if you differentiate that velocity, what you're going to get is acceleration. So you're going to get acceleration, velocity and acceleration if you differentiate this particular equation. See here, velocity and acceleration as at starting. So differential equation with respect to t. Okay, so now ds by dt is your v. If you differentiate that equation, what you're going to get is velocity equation. And now substituting t equals 0 in this equation, what you're going to get is the velocity value. Clear? Why you are substituting the t equals to 0? T equals to 0 means here you have to consider the starting point. At the starting point, the time is 0. Right? And now Again, if you differentiate the equation with respect to t, what you're going to get is d square s by dt square, which is equals to acceleration, right? Equals to, and if you differentiate this particular one with respect to the t again, what you're going to get is this one, and this is your acceleration equals to 6 minus 12 t. And if you substitute t equals to 0 again in this particular equation, okay, in the above equation, which is like a equals to 6 minus t, this is what you're going to get, which is like acceleration equals to 6 meters per second. And the next term, what you have to find is time. When, okay, see a small point here. See, here the acceleration, what you're solving here, you're solving the acceleration when it is varying, right? Here the acceleration is varying with respect to time. With respect to time, the acceleration is changing. That means these are the problems which comes under variable accelerations. Clear? And now here A is that, which is if you substitute at the starting point t equals 0, what you're going to get is acceleration 6 meters per second. And the next one, time. We require time now. So when the particle reaches its maximum velocity, I already said when the maximum velocity is there, your acceleration is equals to 0. And now if you substitute 0 in the above equation here, so the above equation is a equals to 6 minus 12t, right? This is your above equation for the acceleration. So for the maximum velocity, your acceleration is 0. If you substitute here, what you're going to get is the time when the particle reaches its maximum velocity. And what is the maximum velocity? We require that maximum velocity of a particle. Substitute this particular time in the velocity equation. What you're going to get, this is the time at maximum velocity, right? If you substitute this t in the velocity equation, what you get previously, then you are going to get the velocity at maximum. What the velocity is? Maximum. Right? Thank you.